Thanks for a nice introduction. I can't see the future, but I'll try to do my best. So you look great today, actually. Many blue people. That's interesting. That's cool. So, really happy to be here back in Oslo. It's one of my favorite places, actually. All right, so today what I want to tell you or share with you are some stories that I feel might be important for us as developers and designers in general, and also kind of give you an outside of what is changing or how things are changing in this shiny new web that we have today. Now, my name is Vitaly, and I'm editor and co-founder of Smashing Magazine, an online magazine for designers and developers, but most of my time these days, and this is kind of the point, is spent in companies trying to solve front-end and design problems related to mobile, related to responsive design, specifically today, right? So I'm kind of looking into this companies and we're trying to fix problems and I'm trying to figure out what is working and what is failing, which is why many of the things you're going to see today are basically techniques that I saw working or I saw failing. I'm not, I don't care much about what's supposed to be working in theory, but things that actually worked or failed in actual projects. So it's also about design strategy, but not necessarily about the visual design strategy. It's more about how we're going to approach mobile problems in the future to get to results faster. And it's all based on real-life projects. So some things that you might see today, you will not be able to unsee. And I don't take any credit or responsibility for what happens next. But I do want to share them with you just so you kind of know what's happening in the industry. And I feel that many of you have feelings about what is happening anyway. And one of the major things, or major shifts that has changed over the last couple of years significantly is this trend towards modular design, not only in the way we build experiences today, with Android, iOS, mobile, whatever, but also in the way we design experiences. And it kind of goes back to 1893, to this wonderful issue of the Phonographic World, which was published in New York in September, and featured art type, or the art of creating artworks, like this, using a typewriter. At the time, you can imagine it was an outcry. People went nuts about this. Why would you misuse this wonderful piece of technology, which is a typewriter, to create something crazy like this? Nobody understood this. And we still have this today. When somebody sees something like Homer Simpsons in CSS, you might ask yourself, why does it exist in the first place? Who needs this, right? But this is really important because this is what pushes progress. This was 1893, and over time, it's evolved. And this was the Bauhaus time. It was all about function and minimalism. And then eventually in 1939, Julius Nelson came up with this book, which was called the Art Typing Book, which was all about collecting your reusable patterns and modules to create those artworks on the fly, starting with small things like a border. Everybody can draw a border like this. This is not a big deal. To more refined things, like more refined borders, more refined frames, and more complicated frames, and eventually everybody got just bored of this, so they started doing things like a goldfish and a robot, and then a human face and a gradient and the car, and you can see where it's heading. But the point here is, this has brought us something really significant in the 20th century, which was the invention of teletext, or CFX as it was called. How many of you are familiar with teletext or CFX? Now, most of you, for those of you who don't know what it is, this is what it used to look like. And this is how it was supposed to be used. So you have a TV box, and then in that TV box you have buttons that you can click on, you have numbers you can click on to move from one page to another. Now, if we move to our mobile web today, this, back in 60s or 70s or 80s, is a box with content in it. Does it sound familiar in any way? So this is a box with content in it. We have grid, we have layout, we have colors, we have navigation. We know how to navigate from one page to another. We can't tap on things, but we can move between things. So if we look back into what happened back then in 60s and 70s, well, this is how it's supposed to be used. This is the use case of using teletext. And this is how it was supposed to be designed or built. So there were people, hundreds of people, literally poor people in the back room, in the newsroom, creating, designing, and building teletext pages manually every freaking day. And we call designers, pixel pushers because they select pixels and push them. That's not right at all, because they select pixels and move them, right? While these poor people were literally pushing pixels one by one, creating teletext pages on the fly, on one by one. That's a lot of work. The point I'm trying to make here is if we didn't have the web today, most of us would still be teletext developers or designers, which is a big deal because teletext was a really big deal, but in the beginning it was all very predictable. It was not a big deal, it was a box with content in it. But then color kicked in. And with color, everything got more complicated. You know, in the beginning, we're just designing for a little iPhone, and then we call it a day. Right? And then we have this massive amount of form factors and screen densities and everything that we have to really reinvent what we're doing. So what's happening today is very similar to what is actually happening, what was happening back in the day. Because their answer, the teletext designers' answer to the web, to the complexity of teletext pages, was to come up with tools like, conveniently called teletext, which would enable them to create modules, reusable components that would they be able to plug and play as needed, starting from typography to color to navigation to form controls to presets and so on, so they could build teletext pages on the fly, using these test pages to build teletext pages. So the web is different. We still have a box, and we still have content in it. In fact, we have many boxes, and especially in responsive design, we tend to think about many boxes and boxes and boxes and boxes and boxes and boxes. And I think we always do this mistake when we try to think about squeezing content from one box into another box, which is really fundamentally wrong, because the web is way more complicated. Mobile is way more complicated. We have to totally rethink what we're doing. And many of us do it already. So designing for the web today, if you think about it, or designing, whatever you're building, designing for this box today, feels like visualizing a tesseract, with tesseract being a complex hypercube in mathematics, where we build experiences by manipulating the shadows of a hypercube, which is really, really complicated because this is what we're building today, in my opinion. When we're actually talking about responsive design, we're talking about Android, when we're talking about iOS, it's always the same story. We have to put just the right dot in just the right place across all of these dimensions, ranging from navigation to accessibility to performance to typography and so on and so forth. So we create a system that scales up and down according to our intent. And this is really, really hard because there are so many unknowns. This is just a few. Now, we kind of know how to deal with components, right? We know how to deal with grid, navigation, and form controls and things like that. We've mastered this over the last 5 to 10 years. That's not a big deal. Everybody can build it. That's not a big deal. The problem is here. Strategically speaking, we have really major new challenges that have to be resolved. And that's a really big deal. Because if you think about responsive images in responsive design, technically really easy to do. But implementing in a legacy CMS is really, really complicated. If you had to create just 2 variants of image in the past for your product page in the commerce site, all of a sudden you have to create 8 or 10 and crop them properly and bake in the logic into the legacy CMS. This requires effort. That's not easy. We tend to think that we have to optimize for 2 kinds of browsers, smart browsers and Internet Explorer 8. But this is not right anymore. Because Internet Explorer is dying, and that's a good thing, but we have this new breed of browsers like proxy browsers, Opera Mini, UC, and developing for them is really, really hard. And they're growing crazy, extremely extraordinarily in Asia and in developing markets, which are going to outpace us in 5 to 10 years from now. That's a big deal. Also, offline access. We don't have to display a blank screen when a user is offline. We can use fancy technologies like service workers, progressive web apps to really build rich experiences on the web or hybrid apps, whatever you want to build, to really make sure that the user gets something even if they're offline. So there are many things and many moving parts that have to be considered strategically, which is not easy because at the end of the day, we have to bring it all together when we're building layouts as well, right? So that's not easy, and many companies struggle with it. And this is what I'm getting all the time. I don't know about you, but this is always the same story. Whenever somebody is trying to convince somebody about responsive, there is a lot of uncertainty about responsive design because responsive design is very unpredictable. You just don't know how to measure properly how much time you're going to need for it. So there are many attempts to just outsource mobile use case somewhere still, and you end up with this. The CNN iOS app is so bad, I took the unprecedented steps of deleting it and reinstalling it just so I could delete it again. Because there are many, many badly designed applications. And I'm not talking about us being the poor people designing bad apps or building bad apps. This is not right. No, this is not what we're doing. We are trying to do the best we can. But very often, companies try to outsource the mobile use case to something more predictable than responsive design. Because responsive design has to be actively maintained and has to be future-proof, from very small screen to all the way large screens. And that's really complicated. But the future is bright. We have this fancy thing coming out, like progressive web apps, and everybody's talking about it, and everybody's super excited. But in the end, it all breaks down to this kind of overview. We need to figure out what we're going to do with all of this strategically. And designers are trying to reinvent the wheel, more or less. where now when we're designing interfaces, it's not enough to just design a mock-up in Photoshop or Sketch or Illustrator or whatever you're using. You have to do more than this, because you have to consider all the different layers of the user interface stack. The ideal state is probably what most designers are designing in Photoshop and Sketch, but we also have to think about the blank state, which doesn't have to be blank anymore, because again, we can use service workers, for example, to deliver some rich experiences on the screen. The loading state doesn't have a spinning wheel, because this is totally annoying and nobody cares about the spinning wheel. So we can have something like skeleton screens to display at least some parts of content, or the layout, like Facebook does, for example, while the user is loading the app or loading the site. The partial state doesn't have to be broken. We can build on top of microservices and deliver some really rich experiences, even if some APIs are not available. We can also have to consider error state. What is if things go wrong? Or what if the network is not available? What if the network is slow? We can have to consider all the things which make things even more complicated. The complexity is pretty incredible, right? And this is kind of what really forces us to come up with some kind of solution to make things better, to make things kind of have a more systematic approach to it. Very much like teletext designers and developers did with the teletext tool. So in our case, this is what we used to have, this old machinery when we start with traditional waterfall model. And even if we pretend to be agile, we're still doing something like water agile when we pack waterfall inside of agile. Who does that? You can admit it now. That's okay. I mean, perfect agile exists in a perfect world. It doesn't exist. Well, sometimes it exists in reality, but not that often. So this is not working. So many designers and developers trying to do this, atomic design or modular design. How many of you have heard of it or played with it somehow? So the idea or the principle here is really, really simple. And I don't even want to go too much into detail here. But the basic idea is, instead of designing pages, we're designing components. So when we start designing, we never start with mocking up a page. We never start with mocking up the grid. We never start with mocking up the breakpoints for different experiences when it comes to responsive. This is not what we're doing in the beginning. We're trying to set up a system that will be scalable for different platforms. So we'll be starting with smaller pieces of our interfaces, like really small components. In the atomic design methodology, initially, it's all about the atoms, which are the unbreakable components on the web. Think about things like a button. You can't break a button into half a button. That's not how it works. And then you keep combining them. You create molecules, and then you combine molecules to create organisms. You combine organisms to create templates, and then in the templates you add the content, and you have your page. Here's an example, very simple. Label, input, and button, which are the main atomic units. You combine them into a search box, which is a molecule. Multiple molecules, like a search box, navigation, and logo, create an organism. Multiple organisms create a template, which looks like a wireframe, and then you add real content, and you have the page. This is very critical. If you're a designer, or you're working with a designer, moving to this, instead of just designing pages by pages by pages by pages, is really, really critical if you want to get the results fast. This is really, really important. So when you start designing, right, it's not like you're going to Photoshop and create a new canvas of 1,200 pixels times 1,000 pixels and create a page. Instead, you create a new canvas of 5,000 pixels times 5,000 pixels, and you focus on the core essence of your experience. If you're building an e-commerce site, what would make a freaking amazing, extraordinary checkout or e-commerce experience on the site? Think about all the components that are required to make this really perfect experience. Well, probably you're going to display the product, you're going to think about the thumbnails, you're going to think about the comments maybe, or reviews and ratings and stuff like this. So design these components first, and then radiate outwards to all the other things, to all the other components. So the main point and the only difference here is, and I feel even silly saying it here on stage, to move away from thinking about designing pages and the mobile view and the tablet view and the desktop view and the portrait view and a landscape view. This takes way too much time. This is totally unmanageable. You cannot manage this at all, from a designer perspective and from a developer's perspective as well, just building pages one by one. This is just impossible. So instead, think about these components first, and then go ahead as you build. And as you build, you can also use diagrams like this. Again, we're talking about responsive world here, right? Where you can say, for the components that I have designed, I'm going to pull them, I'm going to give them name, and I'm going to define their behaviors ranging from through 6 breakpoints, artificial breakpoints. So here we have XS, which is the smallest, like think about a tiny mobile screen, and think about XX large, which is the largest, something like a TV screen. And what we're doing here is Well, it's not like we're going to map these breakpoints right here into our code, into our front end. No, but this really facilitates the conversation between designers and developers because designer and developer can sit together, go through the components, define the behavior of those components. So here on the smaller screen is going to be this menu is going to be collapsible. And here between medium and large, we have a transition from tablet to desktop. So all the way up to desktop, it's going to be collapsible, like an accordion. And then from a desktop on, it's going to be full with flyouts. Or if you think about this key visual, well, it's kind of a big background image, a wide background image. We can't just scale it down, it won't look great. But instead of creating a new Photoshop mockup for it, or Sketch mockup, or Illustrator mockup, we just say, okay, so let's think about it. So let's ratio 5 to 2-ish up to large tablets. And then from large tablets on, ratio 5 to 1-ish, right? So something around this. And then the developer goes ahead and develops mobile first, while these components are designed tablet or desktop first. And this is where you're kind of moving 2 steps forward and then 1 step back, and 2 steps forward and 1 step back. And at the end of the day, you might end up with something that you can reuse for the rest of the pages, starting with components and radiating outwards, which I think is really, really important because it saves you a lot of time. And as you prototype these components, we always think about this pyramid, where for every component, we are going to make it as fast as possible with the leanest markup possible. We want to keep it accessible, and then when we can afford it, the luxury of having it scalable throughout the different screen sizes, and then maybe adding some fancy styles and transitions and animations and transformations, right? But always thinking about the speed first, accessibility, then scale, and then style. And to be fast with prototyping, we can use this fancy spreadsheet, which I love a lot. This is probably the best thing you'll see, well, in this talk, not today. I'm sure that we'll have more better talks than this one. But the point here is, if you want to prototype something quickly, you can use this publicly available spreadsheet, which lists all the different components, I think around 300 of them, on the left, ranging from basic ones like baseline grid to international font input and all kind of date pickers and widgets and whatever you need, right? So whenever you need something, you can just pick it in this list, and then you can check what frameworks have it. Well, Bootstrap Foundation are right there, of course, but also like bigger pattern libraries and style guides, like Starbucks, for example, are there as well. And so you can just pick it and plug it in your code and call it a day. Now, obviously, this is not what you're going to use in production. But for quick prototyping, this is freaking unbelievable. This saves a ton of time, incredible amount of time. So that's really, really cool. So your entire process really has to be based on components, because this is going to make your workflow way, way, way faster. And I see many designers and developers kind of moving to this space where they feel like, yes, designing and building in components makes sense. And I know that you are building in components anyway, but for designers, it's kind of a new territory which they have to discover first. So responsive is unpredictable, right? Instead of designing pages, we should design modules. And to do this, we need to think about the core essence of what we're designing first, and then radiate outwards from that core essence. And then, of course, think about this pyramid when building these components. That's only one part of the story, though, right? Because it's okay, we can manage this. We can build components, we can design components. Not a big deal. The much more complicated part is how to make it all work in an organization. And this is where people come into place, and people are the worst, because they're so difficult to work with. So the design process is weird and complicated because it involves people and organizations which often are weird and complicated, which is totally true. I don't know about Norway, but it's totally true in Germany. And the reason for this is management thinks that creative process, be it design or development, looks like this. You start somewhere and go. Iterate, 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 agile, pseudo-agile, iterate, 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 and then eventually you hit the finish line and you're done. But this is not like what the process looks like at all. Like, this is not the process at all, because this is way better approximation of what the process looks like. Because we start somewhere and then we expand. We kind of explore all kind of different options, all kind of different frameworks, all kind of different solutions, all kind of different design patterns, all kind of different things that we could potentially go to. And then eventually we might be hitting a deadline, or sorry, a dead spot where we don't know where to move to from that spot. So we have to kind of reroute ourselves and find another way of moving forward. And this takes a lot of time. But this is really, really time consuming. Kind of moving away from here over here can take days, can take weeks, can take a lot of time. So knowing where to go from here is really critical. So this is why I tend to rely on design patterns. And I'm not talking about fancy off-canvas navigation and things like that. But what solutions would work in a given problem? If you have to build a car configurator, if you have to build a dashboard, if you have to build something like a transactions interface, just think about the things that work in other interfaces and plug it in your product. You don't have to map it one-to-one, right? But you might be able to use many of the things that you discover in other interfaces as a solution to build upon for your product. So I think the design patterns, which are totally have this really bad reputation these days, are really critical for us to be able to move forward fast. But moving fast and forward is really hard if you have waterfall. It really is. I don't know, we know this stuff. Linear workflow, designers, front-enders, back-enders, launch. Well, at this point, we may be thinking about users, maybe, right? At this point, we may be throwing in some content, because before that, we only had lorem ipsum, and then basically we have launch if we are lucky. But then we can also make it slightly better, like Watergile, right? Where we have content phase, we have UX phase, design phase, front-end, back-end, and launch. And, okay, so a little bit better, right? But then now we have this responsive design, where we have to cover all kind of different screen resolutions. So what do? We do the same, just now with a bit of dash of responsive design in front-end, right? But then we realize, well, it's not good enough because we have to think about the design, because with design patterns and touch and hit targets and things like that. And we also have to think about performance, so we can't just call responsive design front-end. And the reason for this, why we have linear workflow, is because it nicely reflects organizational structures that we're dealing with most of the time. We have this fancy structures in most organizations where you have people who plan somewhere on the 4th floor, people who design somewhere on the 2nd floor, people who code somewhere in the basement, right? And that's not cool, because these people don't like talking to each other. I'm not the kind of person who likes people, but still, we need to talk to each other. It's kind of an important part of it, right? So what about moving this around a little bit? If you're working in waterfall and you want to move away, but it's really hard because you have really a lot of bureaucracy going on in your company, well, one thing that you can do is try to do the guerrilla thing, where you build smaller tactical teams that are capable of executing multiple rounds of planning, design, and code quickly and independently. We just mingle things a little bit. You just have a project manager and designer and developer working in smaller teams in a smaller feature. And this works really, really well. Here's a good example for it. Otto is one of the major German retailers, e-commerce, and I was working with them. And I was really surprised by the architecture, the front-end architecture that they established, and also the team architecture that they established. So again, it was like 2011 when I was working, when they actually started doing this, but they're kind of following the same architecture and front-end architecture that Amazon is following, which is vertical. So I don't want to go through all of this, but the point is, while they had, as always, a rigid, slow mobile experience and desktop experience, they wanted to mingle it in a shiny, new responsive architecture, and they wanted to have a scalable architecture in all dimensions, be it team, be it front-end, be it design, everything, just be scalable. And their answer to that was to integrate front-end built on top of verticals, as they call it. And the main reason why they did it is the Conway's law. And I'm sure that most of you will be familiar with this, at least feeling the same thing. Any piece of software reflects the organizational structure that produced it. If you have 4 teams working on a feature, you'll get a painfully slow 4-pass approval process. Right? If you have too many people involved, you have to go to too many people in order to make a decision. So they decided to do it slightly differently. They built smaller tactical teams capable of executing multiple rounds of planning and design and development. So they built smaller subsystems, which they call verticals. I just didn't know how to translate it into Norwegian or English. So each vertical is separately deployable entity. This is really radical, actually, if you think about it. This is a very radical front-end infrastructure. So every vertical is a separately deployable entity. It has its own front-end and database. You might be using different stacks. You might be using SMAX in one team. You might be using BAM in another team. You might be using very different methodologies and very different tools. Each vertical has clearly assigned roles and features. They never share any code base nor states. They are autonomous and communicate via REST APIs, working as microservices, right? And this is very different from what we commonly have in most organizations. We have designers, developers, and people who plan somewhere in the other place. So this is what it looks like on Otto, where every single piece of the interface compartmentalizes, and every single compartment or component has actual shared responsibility. So you will have people who do only search. You will have people who do only shopping cart. You'll have people who do only navigation, people who take care of the product display, people who take care of the reviews, people who take care of the related products, and so on. So they build this really many small teams and many small subsystems within that big system that they created, right? So search and navigation system is responsible for any navigation that they have. Order system is responsible for mini shopping cart. Product system provides product details, and so on and so forth. And in every of these systems, you'll have a backend developer, you'll have a front-end developer, you'll have a designer, you'll have a product manager, and so on and so forth. So in the end, building pages for them is not like building, pages. It's more like assembling pages. So each system, each of the subsystems advertises updates and changes, and during integration, each system then is pinged. So when it's integrated, there will be one horizontal layer, which will kind of be pulling all the data from all the different microservices or all the different APIs to pull it all together to create a page, right? Now, I was really surprised by how well it worked for Auto, and it actually works really well for many companies. So if you want to establish a really good front-end architecture, this is the way to go. This is really working. So create vertical systems, like many vertical subsystems, which have their own responsibilities. And for them, it was really like a big deal. And they invested a lot of time and effort into rebuilding the entire thing because they were not agile at all, right? And they did see a huge increase in revenue as well. So when we start working, right, we always think about these components. We always think about designing tablet and desktop first, we're building mobile first, but most importantly, it's really critical to build up teams where designers and developers work side by side. It just speeds up the process, right? And there are a couple of things we have to keep in mind, or we could use potentially. So one of them is a project hub, which is one site with one URL that contains all the different things related to the project. User interviews, performance metrics, everything on one single page. Of course, we'll also talk about pattern libraries, and there are also core content and core functionality priority lists. This is important for performance, because for performance, you can't load the entire site or everything in 1 second. This is not possible. But if you prioritize and push the most important things first, you can get the results faster, kind of to first paint faster. Also, user interviews, performance budgets. If you know what to do with the legacy browser support, if you know your technical stack and tooling, and you have enough time for testing a QA, this is all you need. Now, this is kind of my guideline for every single project. I'm just going check by check just to make sure that I have everything in place. And once I have this, I have a very good sense about where we're going to head. So we kind of have this new fancy tools or strategies for designing and building, right? And that's pretty cool, but it's still not good enough. Because we need to make sure that we're creating systems that actually really scale up and down. And this is where these pattern libraries, or style guides, or style tiles, or asset libraries, whatever you want to call them, come into play. How many of you had a privilege to build something like a pattern library, style guides, style tiles, anything of that kind? So, not many. The problem is that many companies have exactly the same struggle. This is pretty much every single company I was working with. Digital not properly understood. The workflow isn't great. Many design decisions are tech-driven. There is a lot of legacy code base. There is a lot of inconsistency between different views and ecosystems with Android, iOS, and web. And there are many concerns about the right tooling and maintenance because everybody is trying to figure it out, right? So at the same time, everybody is trying this. So many companies are now design-driven, and they know that responsive design works in many ways, so they want to figure out how to make use of it. They're focused on content first. They're focused on performance, which is also a great thing, and they're focused on maintenance because they know if you don't invest into maintenance in the beginning, you might end up with big problems down the road. And so they create pattern libraries, which are seen as an ultimate source of consistency, right? And I'll jump a little bit because there is one way of building pattern libraries, and this is for some reason the way. If you look into what many companies are doing, and many companies are doing this, you'll find this kind of style guides, which are often initiated by designers, which are built by developers, and which are never used. This is incredible. I see so many companies plummeting so much money into building something like this, and it is never used. Like 6 months later, it's dead. It's like a saved PDF somewhere in Dropbox which nobody uses, right? And that makes me very sad. So I had to run interviews with some people just to figure out why isn't it used. And in order for it to be used, it has to be useful, right? This is kind of the point. The point of why we exist, what this stuff exists, is not, to show off on GitHub and make sure that everybody likes it and hearts it and everybody tweets about it. This is not the point. The point is you're creating this system, this reference style guide, so that you, as a product builder, a product designer, can build your product faster. This is the point. This is the reason why these pattern libraries exist. And the best example for it, again, Walmart, it's well documented. It's great front end. Everything is in there. It's all categorized. It's beautiful. It's like when you look at this, you're like, you feel how many decisions had to be made. If you just put two developers in a room, just two developers in a room, and they have to agree on the name of a component, people die in these rooms, right? So they had to go through hundreds of the components to give them names, to come up with proper methodology, to write it all down and come up with the documentation that is maintained and everything. My main problem with it is it's totally useless. It's totally useless for most people in the company except front-end developers or maybe back-end developers. Because what are designers supposed to do with it? Are they supposed to come here and look at the classes that they don't understand, and look at the BAM methodology they don't understand? And what is the point of it? Now, we can make it a bit better. I don't want us to create something like this, which is what most companies are doing, and then just leave it die. And the best example for it is a fall company, General Electric, where they come up with a new way of building a pattern library, building an asset library, which is really, really different from what we're used to. So for them, atomic design, which I mentioned in the beginning, is just the base. They want to extend it on both axes, on the left and on the right. Now here we're just talking about composing pages, like building pages from the components. But we can also do a bit more with this. Because atomic design, it doesn't work well if you think about it on a practical level. Reusable components can be used in many different but similar ways. It leaves room for interpretation. If you see a component table, you need to see where, how it lives within the context of the page. It's not good enough to just see a table, right? Or just see a button. You need to see what the content is like. So it leaves too much space for disjointed experiences, especially if you're building for Android and iOS and others. And a design system should not simply be a collection of UI components along with some design theory. A library that simply provides a kit of parts leaves too much open for interpretation, right? So what they decided to do is really change it by showing examples. I mean, I know it sounds simple, but it's kind of a big deal because they extended the atomic design with two new contexts. One of them is applications and features, and the other one is the principles. So here we have things like infinite scrolling or patterns, design patterns that we tend to use. Are we using infinite scrolling? How are we using infinite scrolling? Are we truncating text? How are we truncating text? Things like that, just to agree upon some basic principles. And here we have examples of what the interface looks like. And it's very interesting because one thing that they do is for every component, they're going to define a JSON file or a config file, it doesn't matter how you do it, and that config file is going to define relationships. It's going to have tags, it's going to have category, it's going to have some links, maybe to a Dropbox folder where that component with the same name is linked to, right? They might contain some things like dependencies or anything of that kind. So every component has associated config file with it. And then, of course, if you're using Grunt or Gulp or any kind of build runner, you can build any kind of view based on that JSON file, pulling information that you need to create different views. And because you have one-to-one mapping between the components you have in your pattern library and the components living in your code base, there is no way to make it wrong. Because this pattern library lives on top of the existing site. You're basically embedding the existing site. It's not like you have to actively maintain a pattern library. No, you don't do this. Whenever you deploy a code to your code base, well, the pattern library is going to be up to date because it lives on top of the existing site, right? And this is great because in every company I worked with, in every single one of them, there is always one person who is so dedicated and so crazy that they're going to push pattern library forward. They're going to talk about it all the time. They're going to go to the kitchen sink and talk to everybody about it. They're going to go to management to talk about it. They're going to set up meetups to talk about it. But they die in 2 weeks. These people die, right? Because once they are really excited, 2 weeks later, they have actual work to do. And whenever somebody has a conversation, right? When somebody says, why are you working on a pattern library? Shouldn't you be working on the actual product? This is the moment when a pattern library dies, right? Because the reason why pattern library exists is not because it's a fancy sub-product or thing that the front-end team does on the side. It should be living on top so you can improve your performance when you're designing and building the websites. So for them, the entry point is this, which they have different views, a front-end view, a designer's view. So if a designer wants to go to that pattern library, well, they can basically check and say, hey, I want to see all the interfaces which contain a search box. And they get an overview of all the interfaces containing search box, because all of the search boxes are tagged with, search box. That makes sense. Front-end developers get a nice front-end view with everything they need, including the components that they need, right? And everything is, again, compartmentalized. So if you have alert messages, you're going to have alert messages.css, alert messages.js, alert messages.psd, and alert messages.sketch. It all has, one name. So that's pretty cool. And you can move it forward by turning the static pattern library into a pattern library API, which is, again, what many companies are doing these days. Where the problem is, what if you have two remote teams, and one living, let's say, here in Oslo, and the other one in Germany, right? And that team in Germany might be reusing some of the code used or written here, right? That's fine. If there is a pattern library, you can go to the pattern library, you can copy-paste a snippet of code, but the problem is that 1 year later, that team in Oslo might have refactored the code, and that team in Germany still is stuck, basically, with the old snapshot of the same code. That's not good, right? So instead, what you can do is say, all right, we're going to build a central API, a central REST API, where if somebody from Germany needs a specific component, let's say component search with a label search, well, that they're just calling it as a pre-processing step. They're calling this API, they're getting this snippet of code, and they're plugging it in. Which means, of course, if you have like breaking changes in your API, you need to communicate them properly before somebody just plugs in the code. That's kind of important. But then this is really customizable, because you can say, if at some point an API supports autocomplete and I need autocomplete, well, that's great. I'm just going to pull it and plug it, and I'm going to call it a day, right? So your pattern library turns away, kind of moves away from the static overview of components with a few HTML snippets and CSS snippets and JavaScript snippets into something like an actual API calls, which could be really highly customizable. And it's called Read, so it's open source. It's been developed by Lonely Planet, and it works really, really well. On top of that, you could say, what if I have hybrid apps? What if I have an Android app, I have an iOS app, I have a Windows Phone app? Well, in that case, you can use Theo, which is kind of the king of them all. The idea there is you define one config file about the font sizes, about the colors, about the branding, about whatever you have in your interface. You push a button, well, actually, you're running command line. Well, let's assume that you're pushing a button. It's fancier this way. You push a button, and then it kind of propagates and creates wrappers for all the different ecosystems and platforms containing the change that you have in your config file. So you maintain your pattern library, or because it's actually automatically maintained anyway because it lives on top of your code base, right? So when you click on that button and you make one change, whoosh, it kind of does it all for you. That's fast. That's really, really fast. You don't have to actively go to every single team, Android team, iOS team, and so on, to make this change. It can be done automatically. So what really works then is to say one-to-one mapping for the components living on the code and living in the design, Markdown or JSON to make fine adjustment in the configuration for every component. We build smaller teams, and we establish this one source of truth so we can propagate changes quite quickly. So that's pretty cool. However, it still leaves one thing not quite finished. This is all fine from the technical and organizational structure perspective, but what about the building blocks that we can use today? What about the technology that we all love? Well, we have PWA, I showed it already once. We have many new cool things coming up. This is just one of them. We have variable fonts. We had lots of features in the fonts in the web in the past. These days, well, soon enough, we're going to have just one container which is going to contain all the different font weights, and they're going to be also smaller. That's a cool thing that's coming up. It's shiny new and just being around for a couple of weeks or so. So that's shiny, it's coming good, that's cool. One major thing that's really changing though is the stack, the technical stack. And I don't know how many of you have heard of the gem stack before. Not many, we have to change this. I'm sorry, we have to change this. So Jamstack is like this shiny new thing, which is living on top of existing technologies, and in terms of the workflows that we're using, it really fits nice and integrates nicely with what we have. So it's all based on top of static site generators with JavaScript, with APIs, with pre-baked markup. So this is interesting because the front end has changed dramatically over the last couple of years. I don't know how many of you remember FTP at all, right? How many of you are still using FTP for deployment? Okay, how many of you are using Git most of the time? Yeah, so this has changed dramatically. If you look into the graph, this has changed just recently. It's not been like around for 10 years or so. It has changed over the last 5 years or so, but dramatically. At the same time, we see many downloads of Gulp and Grunt and Broccoli and all of the task runners, which is really making a big difference today. This is a freaking big deal. At the same time, we have this API economy, which is the emergence of new APIs like Stripe and Discuss and PayPal and Optimizer for A/B testing and Intercom that we can also all bring and build on top of our existing experiences, right, without having to build something in the back, which really changes many things and also changes the way we could be designing and building today. So, good old days, we had a browser, we had a server, we had a static site, we had a server, so when we're talking about 90s, we'll just get content from the server, we'll just push it live, and it's displayed. Then things changed when CGI bin came into play. How many of you remember CGI bin? Who is still using CGI bin? Okay, not many people, right? With Perl and so on, we can actually have some programs. All right, that's been cool, because now we can have dynamic interactive time display, for example, if we want to. That's fine and fancy. And then at some point, of course, with PHP and LAMP stack, when we have Apache and MySQL and so on, we had to come up with other languages like PHP to make this work, and then things got more and more complicated because with the emergence of WordPress, for example, we had to think about, what are we going to do with caching? We need to have high performance. We have like 30, 40 requests to the server, to the database for every WordPress request when you just want to display a page. That's a lot. So how are we going to fix this? Well, at this point, it got more and more complicated. Right? Because I have to think about so many things, like replication and migration and consistent hashing and caching invalidation and so on and so forth. So that's a lot of work. So the new stack now is, what if we kind of moved away, not necessarily back to good old times when we had only static pages, of course, but what if we just focused on the CDN, which in the past used to be just the thing that Facebook and a few other companies were using. Now everybody is on the CDN. This is like a really big deal. So that's cool. So we can deliver content really, really fast. That's great. But of course, on top of this, we need to build in some fancy JavaScript. Now, this is what we're here anyway. So when we push the code, right, in the Git, well, we're going to have a build tool anyway, and it's going to pull content from the APIs, and then it's going to put it in the CDN. So at any given time when you access the page, you're going to get the content from a CDN, right? So there is basically no backend. There is no database in the back, because everything is generated using a static site generator, right? But the thing is, we're kind of enriching the experience by building a JavaScript APIs, or using JavaScript APIs on top of the static side. Pre-built static side. So we decouple front end and back end, and we pre-bake the markup and enhance it with JavaScript. So in the end, it's all about running in between APIs and running in between CDNs. Right? This is way simpler, and this is a remarkable boost in performance. I mean, I'm yet to see any heavily optimized WordPress or dynamic site that can perform better than the statically generated site pre-baked with JavaScript APIs. This was the result. I mean, we improved performance of smashing running on WordPress using LAMP stack and then moved to Varnish and so on. Incredibly, it was really massive. But then it goes no way near to what you can achieve if you use this gem stack, which is basically JavaScript, API, and markup. 6 times faster, and we're not talking about 1 second or so. We're talking about 200 seconds or 300 milliseconds. 200 milliseconds or 300 milliseconds start render time, which is like a really, really big deal. And it all builds on top of build tools that we all love and use, Git frameworks like React, Angular, Ember, APIs, and CDN. Right? So this is what we used to use. Single-page apps, and this is what we normally have, a Git-based flow with build tools and a few frameworks and APIs. This is what we do with websites today, could be doing, and many websites are kind of moving there because performance is a really big thing. Security is another thing. Like every time you see about vulnerabilities and security issues that actually come up in these dynamic environments, so if you're running mostly just delivering content, you don't need this. Right? Because you can just say, okay, I'm going to use the same flow, just use build tools like Middleman, Hugo, and Jekyll, and then APIs on top with the proper fallback, just in case JavaScript is not available. Or you could use hybrids. You can use, again, Git, and then you can pre-bake markup with some CMS, and then enhance it with single-page applications, like with just, it could be a statically generated site with a few React components on top of it, and you can't call it a day. And this brings you really good performance boost. So I have like 100 slides to go through, but what I want to finish up here with is one major thing that we have to look into today is we have these fancy things in front end. We have Flexbox and CSS grids for layouts. We have container queries we can use with JavaScript as enhancement for media queries in CSS. We have responsive images in SVG. We have font loading API for web fonts. We have these fancy methodologies like BAM and SMAX. And the most important ones are the last ones. HTTP2, which is here, and we should all be using it when we're designing or building for the web. And service workers are pushing performance hard. I mean, we moved to HTTP2. It was a big hassle because it requires HTTPS. So it was a big deal. It was really hard, actually. Mixed content warnings, security issues, and certificates, and all the stuff. But the main boost came through using service workers. So if you're just moving to HTTP2, it's not going to be a big performance boost. But if you are moving to HTTP2, definitely use service workers as well. This is going to push performance like hell. Basically, service workers is a proxy engine running between browser and the client. And you can cache everything properly. You can do all kinds of things, intercepting requests. It's amazing. And then on top of this, you can also use progressive web apps, which is just service workers plus a little bit of fancy stuff like push notifications and so on top of it. I'm finished. Don't worry. So service workers and HTTP2, really important. So with this in mind, many things have changed, right? So over the last 5 years, we have changed our front-end and we've changed so many things. Basically, it all boils down to one thing. We design with components, we've built with components, we use this new shiny frameworks, and we use this shiny new front-end tooling tools that allow us to get better at what we do. And we use this fancy new infrastructure like HTTP2 and service workers and Jamstack to really push performance to the edge. Because you can make sure that your website is brilliantly fast and you can deliver start render under 500 milliseconds. That is possible today if you just get things done right. So with this in mind, thank you so much for being here. This is wrong. And I'm looking forward to your questions outside because we don't have time here. So I hope that some of the things were useful, and I hope that some of the things will be applicable to your work as well. So thank you.